And now I'm going to introduce Pamela. So Pamela is a developer advocate for Kotlin Multiplatform Mobile at JetBrains and has more than 20 years of experience writing desktop, web, and mobile apps. So we're very excited here. Thank you so much, Pamela. I'm going to now give it to you.
Thank you very much, Navati. Okay, let me share my screen. Okay. I just want to check out that I can see all my secret stuff. Navati, you can see my screen correctly, right?
I can see it. I can see that beautiful slide there. Yeah.
Okay, great. Hi, folks. My name is Pamela. I'm a developer advocate, as Navati introduced me. Welcome to my talk about Kotlin Multiplatform Mobile for Skeptics. So let's get started. You clearly can see that I have a signature lip color because I had the same lip color on in the introduction slide. So signature lip color is really definitely the way to go. So today we're going to look at a few of the following things. I'm going to start with a brief introduction of what Kotlin Multiplatform Mobile is and why I think it's worthwhile convincing you to give it a try. Then I'm going to show you how to do a simple code sharing exercise using Multiplatform Mobile. Well, of course, one of the most important parts of a talk for skeptics is the part where I convince you that this technology is worthwhile investigating. And in the last section, I'll share some of the most helpful resources that I've found during my research for you to go and check out. I'll also be sharing some links at the end with my slides and with my resource article. So just keep an eye out for those. Let's start with the introduction. So I'd like to begin by just talking about Kotlin Multiplatform Mobile as a technology in general. It's an SDK by JetBrains, hey, and it allows development teams to share common code between Android and iOS, but it doesn't impose restrictions on non-shared code. This means that it doesn't dictate what you share or don't share, and especially not what architectures you use. So it gives you a lot of freedom. Multiplatform Mobile compiles that shared module into platform-specific artifacts that you then add as a dependency in your apps. So if we kind of look on the left-hand side, for iOS apps, the Kotlin native compiler is used to create .framework files or CocoaPods, which you then add and use in your iOS app. If you kind of look on the right-hand side, the Kotlin JVM compiler creates jar files or .aar files, which you then add and use from your Android app. That's on the Android side. I've mentioned that you can share code between different platforms and the decision is yours on what you share and don't share. But there are common scenarios of code sharing. In this slide, you can see that I'm sharing the data or core layers and also the business and domain layers, but I've chosen not to share the presentation or UI layers, and that's completely fine. But we can go one step further and also share the presentation layer of presenters, view models, and controllers as well. It just depends on your architecture. To reiterate, the choice is yours. What then are the benefits of multi-platform mobile? Firstly, it's about flexibility. The flexibility to choose what is shared and what is not shared. If you just want to share like a really complex piece of business logic or something like an important algorithm and start from there and take things from there, you can. Secondly, shared code lowers the effort and cost per feature. Your team doesn't have to duplicate efforts by making sure that everything works the same on both platforms. You don't have to develop and test twice. And this drives down both development and testing costs. Shared code also ensures consistency amongst platforms. I've seen so many times that maybe Android and an iOS engineer in the same team are given the same requirement and they have a slightly different understanding of that requirement for a particular feature. And this results in slightly nuanced implementation differences. I'd like to give you a real-world example of where I've encountered a problem where multi-platform mobile would have been a great choice. I was working at a fintech institution on the onboarding team. And whenever we onboarded a customer, we really needed to get a whole bunch of information and documentation from them to onboard them into our financial system and it was based on their country. So each country had different rules, and we supported a whole bunch of different countries. So if we weren't careful, we could have easily made a mistake in coding the business logic incorrectly across platforms. So we really had to rely very hard on our product managers' documentation and manual testing to make sure everything was working perfectly. In retrospect, this was a perfect use case for a technology like multi-platform mobile to share business logic across platforms. Now, of course, the time for coding has to start. It won't be live coding because of the time required for all the platform and dependency downloads, but I hope you enjoy the coding section anyway. These are the tools that you're going to need to share code with multi-platform mobile on Android and iOS. You need Android Studio with a Kotlin Multiplatform Mobile plugin that you get from the marketplace. You also need the Java Development Kit, or JDK, and Xcode on macOS from the App Store. There is a very nifty tool on macOS called KDoctor that will detect if you've set up everything correctly. So I mentioned this multi-platform mobile plugin before. You can get it from the marketplace, and it's just going to make your multi-platform development just that much easier. It will help you create a new multi-platform project or a library. It will help you write some shared code and then use that shared code on both Android and iOS. And you can even run and debug your app on iOS targets from Android Studio. I'm going to just explain a little bit about how multi-platform mobile works by using the default example that the Kotlin Multiplatform Mobile plugin generates when you create a multi-platform mobile app project. So the example just shows a little bit of text on the screen. On the left-hand side, we've got Android. On the right-hand side, we've got iOS. And for Android, it will say, hello, Android 31 for my Pixel 4 emulator. It's maybe a little bit behind. And hello, iOS 15.5 for my iPhone 11 emulator. It's definitely a little bit behind. So 31 is the SDK version supported by the Pixel, the Android device, and 15.5 is the OS version of the iPhone device. I've taken some screenshots to show that plugin in action. So we use the new project wizard and we select Kotlin Multiplatform App to create the app from scratch. Then the plugin asks us some information about our app, like what's the app's name, what should the package name be, and what is the minimum SDK supported by this app for Android. Next, we configure our multi-platform project to say what should our iOS and Android applications be called and what should our shared module be called. It's pretty much fine to leave it as it is as defaults. And we also have to configure how to distribute how our shared code goes to Xcode using either CocoaPods or regular framework files. Now, in the long run, you'll probably want to use CocoaPods, but in the short while, just to get started, regular framework files is fine. So we select regular framework files. Once the plugin is done its magic, and because it takes so much time, it's not entirely magical. This is what the project structure is going to look like. The Android app will be under Android app. The iOS app will be magically under iOS app as well. And there will be a shared module, and it will contain 3 subdirectories of Kotlin code. Common main is where all our shared code is. And then we have 2 directories, androidMain and iOSMain, where in androidMain, there will be Android-specific integration code that integrates with the shared code is, and on iOSMain, there will be iOS-specific code integrating with the shared code. But you probably have a couple of questions running through your mind right now as I'm talking about the structure of the project. Firstly, maybe you're wondering, did she really say the shared module was written entirely in Kotlin? Even the iOS parts? The answer is yes. It was all Kotlin and even the iOS parts. That's part of the magic of Kotlin Multiplatform Mobile. And perhaps you're wondering, what does this iOS and androidMain and iOSMain mean? What does this integration code do? Well, it basically gives you access to platform-specific functionality or APIs. And this is kind of how it all fits together. The shared code is in the greeting file. On the iOS side, so on the left-hand side, the iOS app uses that shared code. And the shared code makes use of the platform class to access the iOS APIs to get the system name and version. On the Android side, sort of on the right-hand side, the main activity uses the shared code, and that shared code makes use of the platform class to access the Android APIs to get the SDK version from the Android device. But let's have a look at the code. So here we are in common main, and we're looking at greeting file. It has a greeting class with a platform property and a greeting function. If you're very iOS oriented, this might look vaguely familiar. It looks a little bit like Swift because it's Kotlin, and maybe it looks a little like Kotlin if you're familiar with Android, because it is Kotlin. It contains, so we have this greeting class. It has a property called platform, and we have a function called greeting that just returns hello and the platform.name. And this is our shared code. This greeting file is our shared code. Next, let's have a look at the common main platform class. We defined this platform. We saw that there was a platform property here before of a type platform. So let's have a look at the platform class and file. And it contains an interface called platform that has a property name. And that's pretty straightforward, but it also has a top level function called getPlatform that returns something of a type platform. And it has this mysterious keyword in front of it called expect. Now, expect is a newish Kotlin keyword that tells us the code that we're looking for. As you can see, there's no implementation. The code that we're looking for will be found in the platform-specific integration code. But where do we find this code? Well, let's have a look at androidMain's platform file. Notice that it has a class called androidPlatform that implements the platform interface, and it overrides the name property, and it just assigns the value of Android followed by the SDK version of the Android device to that name property. So we're actually accessing Android APIs from this file. It also has a very similar, very familiar looking getPlatform function that returns an instance of Android platform. But it also has an actual keyword that's just in front of the function signature, and it actually matches the expect keyword. It's basically saying that if you were looking for the actual platform-specific implementation, well, here it is. Let's have a look at iOSMain next. So here we are, and we're looking at the platform file. This is very similar in idea to what we had in androidMain, where in iOSMain, we're saying we're defining an iOS platform class that implements platform, the platform interface, and we override the name property. And here we are using iOS-specific classes, functions, and properties to get the system name and system version. So if I were to run this on, I did run this on my iPhone 11 emulator, and it gave me a value of iOS 15.5 back. There's also another function, getPlatform, that returns iOS platform and has that keyword actual in front of it. And it sort of wires everything together. But how does this code actually get on the screen? Well, for Android, it's as simple as calling greeting.greeting and then passing that as state into a text composable. This is using Jetpack Compose. But I wonder if it would be as easy it's easy enough calling, for example, Kotlin code from our Android app, but will it be equally as easy on the iOS app? Well, Let's have a look. For iOS, we define the application like this. This is normal Swift UI code. Let's drill it down into content view. I think there's probably something more in there. So if we're looking in content view, we see that we are defining a constant called greet that has the value of greeting.greeting. And the body of this view is just a text element with this greeting inside of it. And so it's kind of the same idea in a way to the Jetpack Compose stuff, where we're calling greeting.greeting and putting some text on the screen that contains this constant that we've defined. So in this very simple use case, it is equally easy calling the shared Kotlin code from Swift code. To run our apps, we can use Android Studio's Android app and iOS app configurations to run the application on emulators or real devices and see, for example, on the left, hello Android 31 on a Pixel 4 emulator and hello iOS 15.5 on an iPhone 11 emulator. And that's the basics of how Kotlin Multiplatform Mobile works. So what did we just do? We wrote some shared code, and that was just the greeting displaying hello and then platform.name. Very simple, but it can be very powerful if it becomes a very complicated algorithm and so on and so forth. We use the shared code from Android and iOS, and in Android that was used in main activity, in iOS it was used in content view, and we use platform-specific functionality or APIs from the shared code, and those were the two platform classes. Now we get to the tricky part, the part where I try to convince you to give Multiplatform Mobile a try, even if it's just an aside or toy project. Maybe you thought, okay, that looked like an interesting demo, but I'm not really sure if I'm going to give it a try. So it's my job now to convince you. Before I investigated Multiplatform Mobile, and awkwardly before I became a developer advocate for the technology, I had some very critical opinions of the tech. I wasn't sure it would work, and I wasn't sure it would be widely adopted. And here are some of my initial thoughts. iOS developers won't want to adopt this. It's natural for somebody that is specializing in a particular platform to want to work on perfecting their knowledge on that platform and becoming real experts. They're invested in this ecosystem, and they want to ask them now to adopt a technology that's sort of on the side of the ecosystem might be outside of the comfort zone. Next, I thought, will the Swift to Kotlin and Kotlin to Swift interop not be clunky? Am I going to have to deal with really ugly looking Kotlin and Swift code just to get it to work? I also thought, will it really lower the cost of development? There's more to the game than saying there's less code, so there's less cost. There's also other things to consider, like training and skills development and time to get used to and productive in the technology. I also thought, won't it be more frustrating than writing two native apps? Or maybe using something like React Native or Flutter? These technologies have huge support from big companies and huge ecosystems already. They're way ahead of the game. As you can see, I didn't have a very positive picture of Multiplatform Mobile in my mind. But something kept bugging me. I loved Kotlin, and I'm an Android engineer, I have to. No, I'm kidding. I loved Kotlin, and I trusted JetBrains as a company. So I wanted to give it a fair chance apart from my preconceived ideas. So I went through a whole bunch of resources, and I will share a link to the article that I wrote on my blog with all those resources at the end of my presentation, if you want to go and check it out. So I started with just some lighthearted watching and reading. I don't know if you do that, some lighthearted YouTubing and stuff. I watched the short tutorial series on the Kotlin YouTube channel for Multiplatform Mobile with Kate Petrova. And this just demonstrates how to set up your environment and how to code one or two apps with Multiplatform Mobile. Then I had a look at Kotlin's official site to see who was actually using Multiplatform Mobile. Big names like Netflix, Philips, VMware, Baidu if you're from China, That's pretty nice. Next, I saw a tweet by my former colleague, Malcolm Kawenda. So Malcolm and I work together at that same fintech institution, and he is an iOS engineer who investigated the tech, and he also wrote a hot tech article on multi-platform mobile. And then lastly, I watched the Talking Kotlin podcast on why iOS developers are Todoist, the to-do activity, the to-do list, Todoist app company actively pursued using a multi-platform mobile in their apps. I started seeing the potential in the technology. People were using it. They had a good experience with it, and they were starting to get excited. There was definite energy in the air. So I decided to go into deeper investigation with 2 books I noted out. Simplifying Application Development with KMM by Robert Nagy, and Kotlin Multiplatform by Tutorials by the Ray Wenderlich team. And this really gave me a much more solid foundation on how the technology really works. So since I am giving a talk on multi-platform mobile, and awkwardly I'm a developer advocate for the technology, something must have changed my mind, right? And the first thing that really changed my mind was Malcolm's article. I knew him and I respected him. He's a very bright and gifted developer, but he's also an iOS engineer who was willing to give a technology outside his ecosystem a chance. And I thought that he really had a very balanced view of multi-platform mobile. There was hope for this technology after all. And from my research, I concluded the following 3 things. Multi-platform mobile isn't about taking the fun out of native development. For me, as an Android engineer, it's really important that Android developers can continue using Jetpack Compose or XML if they really want to. And iOS developers can use Swift UI if they want to, or something else if they're so inclined. But it's also important that a team can decide what they share, and they can code the rest natively to their heart's content. Furthermore, by enabling a team to share code across platforms, you can also ensure consistency amongst platforms. And this is especially important where very complex business logic isn't concerned. You can write it once, put it under unit tests, and both platforms will work exactly the same. I could see how it would lower cost of development, but not necessarily in terms of money, but in terms of time and effort. But I also realized that initially there was going to be a lot of learning and some frustration that would cause one actually to go slower, but that the pace would pick up over time. I also thought about libraries. I investigated and I saw there were a number of mature libraries supporting multi-platform mobile, Kotlir for networking, Coin or Codeine for dependency injection, and SQLite or Realm for databases. And more is being added to the list as the ecosystem grows. I also saw that it would really help under-resourced teams. In South Africa, where I'm from, there's a lot of Android developers, but not so many iOS engineers. And this would really help lift the burden of responsibility from some very time-constrained iOS engineers. And lastly, I trust JetBrains. They worked for so long on getting Project Kotlin ready before releasing version 1.0. And by that time, it was a rock-solid technology, ready for adoption by a wide audience. I think they really were dedicated to getting this thing working really, really great. But just because I've done my research and changed my mind doesn't mean that I don't still have questions and doubts, even as a developer advocate. And here are some of the things that I'm still wondering about. A criticism that I've seen of multi-platform mobile is that other cross-platform technologies have a much, much bigger ecosystem around it. React Native, for example, has a huge ecosystem of libraries. While I think the most important libraries are there, it's really important that you investigate before you start using it in your app, that you have everything you need. Something inherent in new technologies is, of course, learning. Is there documentation, tutorials, books, other resources, code samples, for example? that are up to date and can be used to learn the technology accurately? Is there a thriving community around it? From what I've seen, the resources at the JetBrains site, and for some folks in the community, it's really like good and up to date. But there are some external articles and code samples that are in the community that are outdated and aren't updated. So you have to be careful where you go look for answers. Something to note is the Slack workspace called Kotlin Lang, where JetBrainers and Kotlin enthusiasts from all over the world get together and ask and answer questions. And there is a special multi-platform and Kotlin native channels on that workspace for talking about multi-platform mobile. My last point has to do with my own lack of experience as on the iOS platform. I was an Android engineer, and I'm sort of learning Swift and iOS on the side, but I have no idea how a professional iOS engineer will feel about the multi-platform mobile developer experience as it stands today. Will they be okay using Android Studio and Gradle to do some of their work? Or will the learning curve just be too steep and too frustrating if there's no Android engineers to help them? But I also wanted to do due diligence and hear what others had to say so I could present a more balanced view of multi-platform mobile. So I took it to the source of all opinions, Twitter. This was a while ago. I'm on Mastodon now. So this was my tweet, and it certainly sparked a very interesting debate. I'd like to go through the points that the camps made, but I decided to anonymize and summarize their tweets to keep it super, super brief. If you're curious on who said what, or get in all the gossip, the link to the tweet is at the bottom of the slide, and I'll be sharing my slide links at the end of the talk. So first up, we have anonymous Flutter Guy, who is a Google developer expert for Flutter and Dart. And this is what he said. He said he felt that not showing the UI is a real con because that's what the real-time server is. He felt that the language shouldn't be the center of a tech decision. In other words, don't use multi-platform mobile just because you like Kotlin. He also rightly said that the resource behind multi-platform mobile can never match the resources Google puts behind Flutter. So in summary, he basically said he felt that multi-platform mobile had questionable advantages and a questionable future. Ouch. Next, we had some multi-platform, anonymous multi-platform mobile guys answering our Flutter Guy. And here's a summary of what they said. They said writing and testing business logic once is a huge advantage. You don't have to commit your entire code base to a new technology. You can start small and keep adding. It also helps you create better looking native UIs in the material design first approach of Flutter. And some parts of your cross-functional team are already familiar with the tools and language, your Android developers. And lastly, we had an anonymous Googler that rounded off the discussion quite nicely. And here is a summary of what he had to say. He agreed the language isn't enough to make a tech decision, and that Kotlin Multiplatform Mobile is different from other cross-platform technologies because the Kotlin native works directly with the native libraries and there's no waiting for plugins. So adoption isn't all or nothing. It's a spectrum based on use case and the needs of the team. And that was the summary of our discussion. I really wish that there was an iOS skeptic that would reply to my conversation. But I want to remind you of our favorite iOS engineer, Malcolm's post that I've added to my little research article on my blog. And I hope that you will go and read it. I think it's a very insightful article. And with that, we're kind of near the end of my talk. I hope I've sparked an interest in you to investigate Kotlin Multiplatform Mobile a bit more than just giving it a thumbs up if you're an Android engineer or a thumbs down if you're an iOS engineer. It's a technology with huge potential, and I hope I've convinced you not to just dismiss it outright. If you'd like to review my slides, you're super welcome to. You can find them with this bit.ly or QR code. The bit.ly is simply KMM Skeptics slides. And similarly, the resource article is KMM Skeptics resources. So this article I mentioned a couple of times, and that's where you can get all my information from. And I also give my opinion on them, so you can decide where you can best spend your time. And with that, thank you. So I am on Twitter still, but I'm also on Android Dev Mastodon. You have to say these things these days.
Yeah, thank you. Thank you so much. That was like a very thorough investigation that you've done on why one can consider KMM. Like, I really like the way you balanced it. Thank you so much. And we have some.
Did I convince you? Did I convince you?
I'm very intrigued. I'm very intrigued.
Honestly, it's good. Thank you.
So yeah, we have some questions, and I'm just getting them here. Give me a second. All right. So yeah, so one question is, why do we use the JDK? Doesn't KMM use Kotlin native?
Yes. So the JDK isn't used specifically. The JDK is used to develop with. It's not used to run with. So yes, KMM uses Kotlin native on iOS, but you have to write your code on a Mac OS that has the JDK installed. You can actually use the same JDK that Android Studio comes with. You just need to point your JDK, your Java home, to the right place.
Great, thanks. And is KMM still available for production use for Apple platforms?
I'm not really sure what it means available for production use for Apple platforms. So Kotlin Multiplatform Mobile is just covers the iOS spectrum. So it doesn't necessarily cover the Mac OS. That is also KMP, which is Kotlin Multiplatform. But you can use KMM in production. Many people are using it. Many big companies are using it. And we are currently in beta, going towards stable into 2023.
Awesome, great, thank you. And also, does Kotlin in iOS, when used in iOS projects, does it impact the build time of the project?
Not at all.
Awesome. Only more convinced then. And Dimitri has a question. Are there plans to expand the reach and the target to Android TV and TV OS?
I think probably under the KMP, the Kotlin Multiplatform flagship. And I think it's a very intriguing question, but I don't really know that much about KMP. I just know that you can target, for example, things like desktop and the browser, and also other platforms like Mac OS and so on. So I assume that eventually we'll get to Android TV and tvOS, but I'm not 100% sure.
Great. And so Dimitri had asked this question, and they also added, thanks a lot for the webinar. I like Kotlin Multiplatform, and I'm glad that I can use it for mobile development, as I'm an Android dev myself. So that's really nice too. Yeah. And then Sierra's saying that this was a really great talk, and thank you so much. She really enjoyed it.
Thank you, Sarah.
And we have another question. So did you have a chance to use KMM in a production environment? What was the use case, and how did you convince management to go with KMM?
Okay, so that's a good question. No, I haven't used KMM in a production environment. But I think that if you have a look at our use cases, or our sort of like star stories section on the Kotlin Lang website, you can see who is using it and in what context they're using it. There is also a resource about how to help your team acclimatize to and become convinced in that KMM might be something for you. So I actually have to admit, I have my eye on a project for a production environment. It's going to be an open source project that I'm hoping to do. I want to do like a Kotlin Multiplatform Mobile Mastodon, just like a play app, and that I can run on my phone for myself. I know there's already a project underway, but I want to do it my own way, as one always does. But I would like to actually get, dip my feet in the waters and try and write that.
That's a great idea. That'll be fun. Yeah, and Srini also adds that this was a great talk. And we have another question. Apart from having to use various packages, how do you think KMM is better than Flutter?
Okay, so I think I do understand this question. I think you really have to look at the use case. If you have a use case where Flutter is everything that you the use case is everything that Flutter gives matches what you wanted. Your designers are okay with everything looking material first on an iOS device. All the libraries and stuff that you need is enabled by Flutter, and your team is already well versed in Dart and they know how to use Flutter, then use Flutter. But if you do have a cross-functional team with some Android devs that already using Kotlin and some iOS devs that already know Objective-C or Swift, you can actually consider KMM, and you can start using KMM in a small way. So you can decide, okay, we've got this onboarding logic that everyone hates to test and that everybody hates to write. So let's share that code and start building it out from there onwards. And see if it works for you. And especially on the Android side, because it's already Kotlin, if it doesn't work and it absolutely sucks, you can always just copy the code back into the Android base and you're fine. And then on the Swift side, you just rewrite the Swift stuff in your iOS app. And so it's a very low risk approach that you can take. Whereas if you use something like Flutter, you have to commit to using Flutter. You have to learn Dart. You have to learn how to get all the widgets and stuff working correctly and that everything looks nice. You have to convince your designer that material design is really cool and it's going to look nice on iOS as well. So it really does depend on your team. I don't think there is a single, there's not a single answer for everyone. But maybe KMM is for you if you sort of in that scenario.
Awesome. Thanks so much for that. And Manish also adds, thank you for the informational session. What type of tooling support is available from the iOS side for debugging purposes?
Sure. So there is debugging support provided by a company called TouchLab that have a plugin that you can use to debug the shared code from iOS. And it works pretty well. So there is some tooling on the iOS side for debugging the shared code.
Awesome, that's great to know. Yeah, and I was sharing your links. I think I got hold of one of the links at the end, and I look for the other and just send that as well. But this was extremely informational. We are very convinced. And yeah, I think I need to learn Kotlin, which I'm sure should be fairly easy knowing Swift. And then
if you know Swift, you almost know Kotlin. Kotlin is easier than Swift. Swift is a very nice language. I really like it, but it's also very detailed. Kotlin is a lot simpler than Swift.
That's good to know. I might just end up switching platforms if that's the case. That's awesome. Thank you so much. We really enjoyed this. And also, I really like how you mentioned your lipstick color, because I really like your lipstick color. And yeah, I think there was a question around like what, like we'd love to know the brand and the shade. And
It's
Oh,
MAC.
of course it's MAC. I think MAC really has good red lipstick. So yeah, it's great. All right, thank you. Thank you so much.
Thank you, Navati.
We really enjoyed this, and we'll see you soon. Thank you. And thank you everyone for attending. And yeah, have a great day.
Thank you
Bye,
for
folks.
inviting me. Bye-bye.
Bye. Thank you.